Recording, you're good to go, Rich.
Okay.
Precious, you want to kick us off, or it's want to do a quick intro?
Yeah, so sorry, I'm still trying to like do a little setup and also like get my info in. So yeah, welcome everyone to Tublian. Um Welcome to Tublian Masterclass. We do this like every month where we get to teach you like on interesting engineering topics and then things that you need to know about, especially in the area of open source. And also we normally upload it on YouTube. So if you go to our YouTube channel, you are going to see a lot of our videos about a lot of the videos from our past master classes. Yeah, Tublian is a platform that help junior devs to upskill their career and helps the senior ones to get visibility, to get known, right? So, and then we are doing this by building a lot of AI enabled tools that can help you to like contribute to open source, find look for job application, and a lot of other amazing stuff that we are doing on the Tubular platform. And I want to say welcome to everyone once again. So our guest is on a call, Rich. I will allow Nilanjan to introduce him just so that we don't take a lot of time. So towards the end, I'm going to make all the important announcements, and then towards the end, we are a lot of some of the important announcements we are going to make towards the end is we are going to announce those that won the prompt engineering challenge that we had from our last month masterclass. We are going to announce that towards the end. We are going to give a lot of insights on the internship that we have coming up. So if you're really interested in the internship, I think you should stick around. And then if you also participated in the prompt engineering challenge, you should stay around. Once Rich is done with his session, I am going to like announce. I'm going to announce. We are going to announce the winners, and then we're going to announce the updates on the internship. So yeah, me and Lee can go and introduce Rich. Yeah, thank you.
Yeah, thanks, Precious. Thanks, everyone. I mean, one of the reason I wanted to do this session is obviously Rich is an awesome guy. We used to work together back in days. And this is also a very important and interesting topic for me. Um, I feel like the key skill you can have as a software engineer is an ability to work with legacy code bases. Most likely in your job, 9 out of the 10 projects going to be thrown into an existing code base, legacy code base. They will point to some Jira ticket which you have to take and solve that problem. Which is interesting also is exactly what you do when you contribute to open source. And next month is an interesting month for open source, which is essentially called Hacktoberfest. And we are also doing some interesting stuff for emerging devs, helping them to contribute. So all this timing and everything, this presentation is perfect for us. So if you're interested to contribute to open source, if you're interested to actually get better as a software developer, this is a must. I'm really, really excited about this topic. So with that said, I'm going to hand over to Rich and he can kick us off. Hey, Rich.
Hey, how's everybody doing today? Normally I tell a joke at this point, but I don't know any good jokes. So I'm going to skip the joke thing and just jump right in here. So I'm Rich Domkaler. I'm presently the Vice President of Enterprise Architecture at Construct Connect here they're an Ohio-based company. I've been coding since I was about 10 years old. I've made a couple of open source contributions that successfully got merged. I'm a big supporter of open source. I really think that the open source community is a fantastic place to grow and learn and gain experience, and also a great way to share what we know and what we've learned with others, and make the world a better place. So let me start by saying that when we think about open source contributions, or when we think about these things that are not required for our job, right? We have to make reasonable choices. We have to consider, why are we going after this problem? Like, are we doing this because we're trying to build up our development skills? Are we doing this because we're curious about a particular platform or the architecture of that platform? Or is it we're scratching an itch? And scratching an itch, I think, is one of the best reasons to go after an open source contribution. You're using a tool, you like the tool, but it is lacking a feature or it has a bug, and you'd like to contribute and help. And if you read the licenses, you know, they talk about giving back and all of that, and that is the mindset and the mode within open source, is that we're a community and we're trying to build something together. So if you don't have an idea of what to do, but you're still looking to build those skills, another great way to find stuff to do, right? Like, what am I going to do? Is go look at the issues list on an open source repo for something you're interested in. So go to the Tomcat repository, or your favorite mocking tool, or your favorite security library, and read the issues list and see if there's something there that interests you, something that you'd like to dig in on and try to solve. If you're doing this because you're scratching an itch, if you're doing this because you need something in and you think it belongs in that tool, sometimes the answer is not use that tool, but rather create another project. So keep in mind that creating your own project is also an option. You can go out onto GitHub, create a repository, establish it as an open source project through their process, and declare your own rules and build your own thing, and that's good too. I've made attempts at that in the past, and I'll say due to probably attention deficit disorder, I have not succeeded. I've built them and then never quite gotten them deployed to Maven or registered with the NuGet libraries or anything like that. So I strongly encourage you to try that if you're interested, but unfortunately, like I said, I got to the point where it creates the jar file and then I never went and got it stuck into Maven and did all of that last bit of labor. And that was many, many years ago. I don't think the library is very interesting anymore, but it was a lot of fun. I learned a lot. I learned a lot about how to, shameless plug, good. I learned a lot about how to, structure things so that when someone else consumes them, they make sense, right? And that translated into good work habits at the job. So now when I create an SDK or I create an API, I have an appreciation for how do I communicate not only to the consumer of my product, but also the other developers of my product. And that creates sustainability within the organization. So that's sort of the broad strokes of what I think about contributing to open source. I think it's a fantastic activity if you can do it. So let's talk about how we get there. The first thing you want to do is create stability for yourself. We have busy lives. There's many things going on. The last thing we want is to discover late that we have not thoroughly set up the repository stably and figured out how to run it and figured out how we're going to make a contribution. So start by reading the license, the README, the contributing guide, any public documentation you can find about how to make a contribution. Go scour the issues list, understand the community. Those are ways to find out, how is the system intended to work? Find out, another thing to find out is the project still active? There have been libraries that I've wanted to contribute to, and I find out that they haven't been touched in 10 or 12 years. And as a consequence, nobody's really paying attention. So my merge request might never actually be merged because there's nobody at the wheel. And I don't, as a contributor, I don't have the authority to do it myself. There are ways around that. You can try to contact the authors and ask if you can take over the project because you'd like to bring it up to the next level. That has worked for us in the past. Years ago, we tried to build our own version of Jira, and we grabbed a product called XPlanner off of GitHub and made gentle requests, and eventually they gave us the authority to move forward. And we were outpaced by professional agile lifecycle management tools, and so we stopped that project. But it was an interesting experience to say, okay, well, now we're running an open source product. that we've inherited, what are we going to do? But go and explore. Find out what the guidelines are. Some of the products out there now, Rust in particular, have very stringent guidelines for how you make contributions. They have a code of conduct that is extensive. You want to understand that culture because you're a guest. As a contributor, if you're joining an existing project, you're a guest and you want to conform and be a good citizen within that community. Other things you can do, join their Discord or their Slack channel, or if they're on IRC, some of them are still on IRC, go get an IRC client and join up. Listen to the conversations and participate. Find the community leaders. So many times there's a community leader or set of community leaders who sort of hold the philosophical picture of what this tool is about. Get to know them and communicate with them and find out, if you have an idea for a feature or something, run it by them first. One of the things that is painful to learn about open source is not all contributions are accepted. So you want to make sure that if you're going to add a feature to a system or you're going to change the behavior of a system, that everybody within the community approves of that. Or you may find yourself with a merge request that never gets closed. So having said all of that, let's go back to the stability thing. So you've learned all this about the community, you've learned about how to interact with the team, and you've pulled down the code. And now you want to make sure it builds. You want to make sure that the build pipeline that runs locally, which is, going to be a Maven script or Gradle or, who knows, it might be a Bash shell script, something like that. Make sure that that runs cleanly and it can do all of its things. And you want to do this in a way that says my system conforms to what they need. So because you're contributing in this large community of people, it's difficult, not impossible, but difficult to say, hey, I'm going to change the build script so that it works. Because if you change it for yourself, you're now affecting potentially hundreds or even thousands of other contributors. And that can be a challenge. So especially when you're starting, when you're an unknown, when you're not yet a well understood member of the community, do what you can to make your laptop or your desktop computer conform to what it needs. And if you get stuck, go to the community for help. You're probably not the first person to experience whatever pain it is that you're having around that build. So, jump on Discord or Slack or whatever and say, hey, I'm new to the community. I followed all of the instructions. I've done all of the things, and this still won't run the tests, or it still won't compile. Can somebody help me out? And you'd be amazed at how much the open source community is willing to jump in and help you out. So familiarity with the system is important. Scour the documentation, read about what are the guidelines for contributing. Are you supposed to fork the repository and come back with a merge request through that fork? Is the team using a trunk-based approach? How do they handle merge requests? Understand that it's different from project to project, and the rules are different. You want to know what those are. You want to understand if you're employed, if you have a W-2, I don't know, internationally, I don't know how to say this, but if you're employed by someone, you want to understand what your legal obligations are and restrictions are. So I've worked in organizations that do not allow open source contributions at all. I've worked there where you can do it, but not on their equipment. And I've worked in organizations where you can do it and on their equipment, and even organizations that encourage you to do it. They ask you to take some time every week and make a contribution if you can. So find out what those rules are. You don't want to get in trouble, and you don't want to start a legal fight between your company lawyers and some open source community that you really appreciate and we're trying to help out. After you've done all that, right, read the build script, understand when and how it compiles. What is it doing to validate the software? Is it running JUnit tests? Is it running Rubocop, Cucumber tests? Find out what those things are. Find out if they, try to understand, will that stop the build if there's a failure? What kind of reports is it generating? What kind of static analysis or dynamic analysis is it doing? So a lot of times teams will use tools like Valgrind or PMD or Splint to detect flaws in the code that comply with the team's agreed upon standards for quality. And you want to understand what those reports are, how to read them, where do they get produced, and very important, do they actually fail your build if they detect an issue? I've had a couple of experiences where they don't fail the build and I think I'm okay, and I make a merge request and I get feedback that says you're failing the build because of this report. I'm like, I didn't even know we were generating that report. So going back and understanding exactly what's happening inside of those builds is a good starting point, and it'll give you a sense of, how does this beast run? How is it validated and proven to work? Another thing to understand there is also CI servers. So a lot of open source projects use CI servers like Travis or Circle and some other, I guess now a lot of people are using GitHub Actions to do builds on GitHub to validate them. Understand if the build script runs differently when it's being run by the CI server. Does it have differences that might cause you a problem? For example, environmental settings or versions or things like that, because you may need to adjust those things as you're working, either on your local system or understand how you're going to need to adjust them on that CI server to accommodate what you're building. I've said this before, but I'm going to dig in a little bit deeper, right? So conforming to the rules. The contributing guide of an open source repository is essential. You need to really understand what the contributing guide is, and some of them can be very long and very complicated, and some of them are trivial. I think that the shortest one I've ever seen said something to the effect of, please be a good citizen and do whatever you want, and we'll work it out in the merge request. And the longest one I've ever seen, I think, is Rust, which is several pages of information about how to make a contribution. Understanding that contribution guide will get you a better assurance that at least they'll look at your contribution. So understand what the norms are there. Understand how they want the submission to be made. Understand how they want to branch to the source code. So assuming it's Git, which most modern software, most open source software uses Git now. Some of them use older technologies like SDN, but understanding how they expect you to construct your request is important, because if you do it wrong, they may just reject you straight out and say you didn't follow the process, and then that you're creating work for yourself. So a little bit of pre-work up front, it shouldn't take long, and understand that. Obviously, as we stabilized the system, we had to understand what tools we needed. Did I have to install Python? Did I need a bunch of libraries that I didn't have? You may also need to, as a contributor, have additional tools. So some systems run just fine as packaged, and they're great. You can just take the output and use it. But when you want to be a contributor, you need to add tools to your system as part of the build chain. So understand those things, and you'll probably find that in the contributing guide. I think I've mentioned codes of conduct, but you want to make sure that you read those. Some groups are very particular about the code of conduct, and that can include the naming of things, the writing of the documentation, and the use of pronouns. Oftentimes you will find contributing guides that link to codes of conduct that suggest that somewhere in there they will suggest that all documentation be written in a gender neutral tone. There will be rules and guidelines about naming things in a way that is friendly to the community. And that can sometimes get pretty complicated, and you want to be aware of what those rules are. Another thing that's related to this is find out if any of these norms or any of these guidelines are automated or automatable. Are there ways that you can ensure that you conform to those rules, get the computer to do the work? So running all of the static analysis, maybe the default script doesn't run the static analysis, but you know that the CI server will fail if there's an objection in the static analysis. Figure out a way to run the static analysis on your laptop. Guard yourself against the potential pain of, hey, I did all this work, and I'm really excited, and I can't wait for you to accept my merge request. Oh yeah, and the spacing on this line is wrong because I didn't automate that, and and I missed it. So you can save yourself a little annoyance or suffering that way. So exploration. And this applies to open source and to closed source professional development, especially as you're new to an organization and you encounter large code bases. At my organization, we have some code bases that are 20 years old. Some of them are huge, tens of thousands, if not hundreds of thousands of lines of code, with design and style techniques that predate some of the careers of our engineers. And so it can be an interesting landscape because 20 years ago, we didn't do things the way we do now. We've learned so much. We've developed design patterns that are really solid, changed architectural frameworks, changed structure. But you may easily encounter in open source and in closed source some very unusual or unexpected architectural artifacts and engineering techniques. One of my favorites is that I keep finding source code files that have passwords in them, or security keys that require us to recompile a system before we can redeploy it. So when we do a password rotation, as an example, we have to go rebuild the application to get it out into production. That's a terrible architectural pattern, and if you have a chief security officer, they will be jumping up and down for you to fix it, and I, as an architect, would tell you, you really got to fix that. But it's not at all uncommon, especially in less regulated organizations, to find that kind of stuff. You'll find, differences between what you've read in a textbook or what you've learned elsewhere as you join these projects, and sometimes you'll be scratching your head. So explore them, dive into this sort of maze of code, figure out how it starts, figure out what design patterns might be apparent. So understanding that the visitor pattern is being employed or a chain of command pattern is being employed, understanding that there's a domain context and that this is, hexagonal architecture. And so we've planted the domain inside of a set of buffers and barriers to adapt us to the environment around us. That's going to help you immensely as you think about, well, how can I contribute and where do I put my change? How does my change fit in? And again, being a good citizen, you want to conform to those architectural patterns, especially as a new member of an open source team. Significant changes to architecture are going to be met with resistance. People will question it and they don't know you yet. So you want to be careful with that and say, hey, I'm conforming to the style, and oh, by the way, it'd be easier if, and then have that discussion. Leverage the documentation. Go find out where the top secret, engineering docs are hiding. They're probably in the repository somewhere, but there may be some cache of information on Discord or in a Slack channel that you don't know about. Ask questions, talk to people, and find out where that is, and then read that too. Keep in mind that, wherever you're coming from, you may be familiar with some frameworks, like Tomcat is my example here. You've been developing with Tomcat because it's free and it's open source and it's a great servlet engine and everything is fine. And then you join some project somewhere and they're using a different product, Glassfish or WebSphere or something like that. Conceptually, these tools are the same, but what you'll find out is that there are differences that you need to be aware of. So do your research and understand if the tools aren't the same, do your research and understand the differences between them. It'll help you out in the long run. If you don't know, you don't have a good idea for how to detect the architecture and you're just looking for ways to find your way around, pick a favorite feature, right? So, one of the features in Python that I like is they have actually done a really good job of building fixtures and doing really cool things with how fixtures are applied. Pick a feature like that and then go understand how it works. Dig around in the code and just explore. How does this part work? How does that part work? These two parts interact with each other. How do they interact? How are they aware of each other? that'll give you a way to find out, because you're familiar with the feature. It'll give you a way to find out, well, how's that implemented, and it will help you understand how to implement what you want to add. Do that more than once, and you'll get even better understanding. If you pick two features that are really unlike each other, that'll really give you a better sense. So I think it was 6 months ago, I dove back into the Cucumber code base to understand how the -- publish option works, and found that they had done some rather significant structural changes in the code base from the last time I'd been in there. It was super informative because it changed my understanding both of modern Cucumber and its implementation, but also my understanding of how people are thinking about optional functionality. And I discovered, in addition to reading that code, I discovered through the issues blogs a lot of conversation about that change and how they'd arrived at this is a good idea for a change. So my experience tells me that these 2 or 3 techniques are super effective at helping me understand a code base. The main output you want from this is you want to feel comfortable that where you're putting your code makes sense and that it's going to work well with the framework, so that, again, when you go to that merge request, you're not fighting against, well, architecturally this doesn't fit. You've come up with a whole different way of things, and now the authors the owners are confused. And that'll help you professionally as well, right? Playing along with the rules within a repository leads to less friction in trying to get work done. So validating, this is really important. It's important to understand both how the open source library or a commercial library validates itself. So how are the tests being designed and created, and then how are they executed? How are we validating style? How are we are we running a check style application or a PyLint application or something like that to verify that we're conforming with style rules? Each community in each language has sort of its idiomatic behavior. It's sort of natural language. So an experience, in Python will tell you that not all Python projects are structured the same, and it is relatively easy to get Python developers to disagree with each other about the structure or the format of code. And they will disagree with each other about how to test things. There's some enclaves of test mentality within Python that say never mock anything, and there are others that say mock everything. And that's probably true in many, many languages, but my most painful experiences there have been in the Python community of getting merge requests rejected because I used a mock in a test. So understanding how the team likes to do it, and then understanding what's sort of the natural language and style within that community and that language is important, and understanding it for yourself so that you can be as effective as possible in developing your own automated tests. So how do you figure that out, right? One thing is to go break something, and this is relatively easy. You've done some exploration, you understand one of your features, go to that code and change something intentionally, reverse a logical condition or delete a line that looks like it writes to the database or something like that, and run the tests and see if anything breaks, see where it breaks and how it breaks. What notification do you get? It's interesting to see if there's a cascading effect, but it's more interesting to understand, well, what is the validation framework going to do? And then as we think about things like style, go change the spacing on a line of code somewhere. This is a source of frustration for me, is code style checking that checks to see if you have got the spacing right in a logical condition. So maybe you have a bunch of parentheses and a whole bunch of operators and whatnot, and if you get that spacing wrong, the style checker will fail your build. understand if it's going to fail the build or is it going to automatically repair the build. Are we using a tool that enables us to, automatically fix that? So like RubuCop in the Ruby community has a --" fix flag, and it will fix a lot of your violations for you. And so it saves you some pain and suffering, but RubuCop will also report those errors without fixing them if you like. So play around with those tools and understand them, because in order to participate in this community, you're most likely going to have to leap that hurdle. On the professional side, you should still be using these tools in your professional community, and you should know how they work for that community as well, because having your code clean and easily read and formatted consistently pays off in the long run. Not interested in knowing if, Amitai wrote the code or Rich wrote the code. What I'm interested in is, what does that code do? How was it tested? And, can I read it? So it's the benefit of these things, right? Another thing to consider, or thing to think about, is, when does the build stop? I mentioned this before. Does the build stop if I violate these rules, or only warn me? If it only warns me, understand how to detect that warning, and then my recommendation is clean it up. You want to live in a world of no warnings and no errors. No compiler warnings, no interpreter warnings, no style warnings. When you see those things, those are indicators of there may be a problem here. Go and address it. Even if addressing it means turn off this rule that I'm being warned about, make sure you do that, because if you're not doing that, what ends up happening is you end up with so many warnings that you start to miss errors. The output from your build should be relatively clean. It should be like, hey, I'm running the compiler, I'm running the test. The tests passed. This is how many tests passed. I ran the static analysis. It passed. It should only really put out a lot of output if there's a problem. If it's not that kind of world, it's very, very easy to make a mistake and not know that you've made a mistake. My favorite story about that one, 35 years ago, I was an assistant systems administrator, and we had a backup job that output a lot of information. And if you think about network backups for large communities, they're kind of like giant compiles, except what they're doing is copying files instead of assembling executables. And I missed in the output that we had missed a machine. And so it missed its weekly backup, and was very embarrassed 2 weeks later when that team came back and said, we need to go back to this restore point, and we didn't have it because I hadn't observed the output. But that was where I learned that the volume of output was hiding the possible errors, because I'm a human being, and I'm just like all other human beings. Like, I get a little bit lazy. I'm like, I've run this backup 60 times before, and it's never failed once. So I just kind of quickly scan the output. If I don't see an obvious error, I just move on with my day, and I made that mistake. So fortunately, I did that really early in my career. I was, 17 or 18 years old or something like that. And so now when I think about this output, I think about, that's so much information. How do I know if I failed? Can I make it more obvious? Other things you want to think about, the 10-second, 10-minute rule is a good thing to think about. Find out how long the average build takes on your machine. You want to shoot for 10 seconds for running unit tests and 10 minutes for running them all. That's a good objective to have. If it's much longer than that, you get distracted and you become less likely to run those tests. So if you can figure out how to get your systems into that mode, you're getting feedback rapidly, and that rapid feedback is going to help you immensely in making sure that you run those tests. The discipline of running tests is really important, both as an open source contributor and as just a professional software engineer. Make sure you're running those tests as frequently as possible. Find an auto test tool that just runs them all in the background constantly. Do whatever you need to do to make sure that you're executing them. And that, by shortening that runtime cycle, you'll get a much better, much more convenient experience. I've worked in systems where the build cycle is 8 hours long, and it's terrible because I build something, write some new code, and I start building it. And now what am I going to do for 8 hours? Probably I'm going to go find other work to do. And when I do that, I distract myself from the problem I'm working on. And then when that build fails, I'm left with, well, what did I do wrong? I've forgotten. I'm working on something else now, and I have been for 8 hours. So getting it down to 10 minutes, that's going to really be super helpful. And that contribution back to the open source community would generally be appreciated if you can find a way to speed things up. Next thing, analysis tools. I've talked about this a little bit. The analysis tools like PMD and CheckStyle, PyLint, JSLint, Valgrind, and Veracode are very useful within the community. You want to understand how and when those things are executed and what the rules and guidelines are, especially because you may be adding code that does something beyond what's been considered. So if you needed to change those tools, if you needed to change the configuration, you want to understand how the open source community accepts that kind of a change and make sure that it's clear within your pull request that you've had to add a rule or change a rule in order to accommodate your change and justify it. Professionally, you will generally run into the same set of constraints and rules. You may have a little more latitude professionally, actually, than you would in an open source community. But understanding those things is really important, and they're going to lead to much, much higher quality results in what you build and what you do. So, don't abandon them. Excuse me. And I think I mentioned this before, Rubocop Fix and tools like that, figuring out a way both to automatically run all of this analysis as you're developing, like IDE plugins or other auto runners that you can do, auto format, things like that, and figuring out if you have tools like Rubocop that can fix some of your problems for you is super important. You'll save yourself a lot of time. One of the things that always made me crazy in Python was PyLint would come back with a laundry list of 100 problems because it didn't like the way that I write code. And I had yet to discover a way to auto fix all of it. And then I spent hours going back and changing little silly things like the spacing here is wrong or the capitalization here is wrong. So finding those tools, super helpful. All right, let's get back to, we've picked a problem. We've decided that some issue on the issue log is something we're interested in fixing, but we're new to this code base. We're relatively new to, open source communities and whatnot. What are we going to do? Strongest recommendation is keep it as simple as possible. Don't take on climbing an entire mountain when you haven't even stretched out, right? If we were going to climb a mountain, we would stretch out before we went on that trip. So pick a simple thing. Pick a portion of the problem, make it as small as you can, and try it. See if you can get a change into the code base and still get everything to pass. And it can be really crazy simple. You could, as an example, add a logging statement. Maybe you're going to remove that logging statement later, but add that logging statement and run that build. Then enhance that a little bit, add a little bit of logic. Work your way up to the problem. If the build is really fast, if it's 10 seconds or so, that'll take you only a few minutes, but it's worth it to start your exploration and understanding the side effects of what you're doing. Accept that some of the stuff that you're going to do is going to fail. You're going to make a change that you think is harmless, and the build's going to fail. And that's okay, because failure is learning. And pardon me, failure is learning. And you want to learn as much as you can, as quickly as you can. So embrace the failure. Don't let it get you down. Be like, okay, I failed. What did I learn? Take a second, think about it, ask some questions maybe. Be really curious about why you're failing, and then you'll learn something. And that, that thing that you learn, it may be the thing that changes your career and makes you into the super programmer you hope to be, or it may be a thing that teaches you what not to do in the future. So certainly there are code bases out there that have some terrible design patterns and some terrible habits that you have to conform to contribute to the open source. What would you learn as a professional is don't do this, because look at the pain it's causing. I once worked with a team who was storing key value pairs in their code as a combination of the key and then a GUID into their database. And they used that GUID to look up the value out of a key value pair database. And their maintenance cycle, every time they changed one of those things, was ridiculous. Their design pattern made it very awkward when you wanted to introduce a new constant into the system, because its value needed to be stored in the database, and oftentimes only for the purpose of satisfying an interface in the code. Nobody else used it. It was just a Sentinel flag, and it was a terrible design pattern. And I learned from that, don't do this. It's way too much work, and it slows you down. The other thing to think about is, we call it small bets, right? So I bet if I change this line of code, it will fix my problem. Is a good bet. I changed 1 or 2 lines of code. I ran the tests. They failed, and I got my feedback right away. That's much better than I changed 3,000 lines of code, and I think it's going to work, and I haven't run the tests yet. So making those little tiny bets and then validating as soon as possible, that's the way to get there incrementally. Also, there's a thing that I call abandonment syndrome. I personally suffer from this. I have a tendency to grab a hold of something, absolutely convinced of the correctness of my implementation or my solution to a problem, and I won't let go of it. And I will spend more time than I should. I won't give up. And I think that learning to let go is really important. So abandon the code, delete the branch, throw it away, and start again. Take what you learned. Why isn't this working? Sit back and analyze that, and then move on. That's an important skill, especially on complicated things. I have done the thing where I spent a week working really hard on what I thought was the ultimate implementation, to discover that it performs poorly, and I've missed at least 3 use cases, and with some reluctance then had to delete all of the work from the prior week and start again. It's going to happen to you in open source. It's going to happen to you professionally. Get comfortable with it and learn from me. Don't wait a week. It doesn't hurt as bad if it's only a day of work. It hurts a lot when it's a week. Last bit is open-mindedness. Where you're working today, in the code base you're working today, you may be the most knowledgeable, smartest, most clever, most talented person on the team. But when you're joining a community, those folks don't know you. They're not, your experience to them doesn't mean a lot. So be open-minded to what they're doing and how they're doing it, and gentle about your presentation on your ideas. Be considerate of the fact that this is a community of folks who spend a lot of time thinking pretty hard about how they're building systems. And you may learn something. Again, you might learn what not to do, but you may learn a new technique or a new style or a new part of the technology stack you were unfamiliar with. And setting your ego down and being open to all of that, really powerful. And that, I think, will enrich your experience in open source. On to keep it clean. So keep it clean. This is, you'll read about this with, Robert Martin and others, and the Boy Scout rule and phrases like that, right? It's important to both keep the code that you're creating clean, but also, to clean the campsite as you're there. So the Boy Scout rule says, leave the campsite cleaner than you found it. And that comes from the Boy Scouts of America. And when I was Boy Scout, that's what we did. We went to the campsite, we camped, on the day we left, we literally scanned the ground and picked up every little piece of debris, every little piece of garbage. And our goal was to make sure that that campsite was at least as clean, if not cleaner, than when we got there. When you go into a code base, whether it's open source or professional, you want to make sure that it minimally conforms to all of the style guides and conforms to all of the rules and design patterns that are employed. But you also want to make sure that anything that could be attended to while you're there is taken care of, so that it's cleaner than when you got there. Keep in mind that there's a boundary condition here. You want to understand what the community standards are, and you want to understand that the cleaning that you're doing conforms to those standards. Mistakes I've made. The list is very long. You go into the code base and you see something that you think is a mistake, and you end up fixing it, and you change maybe a half dozen files in order to fix it, only to be admonished because you've now violated a guideline for that code base. And so that work became waste. And you might not find out about it until the PR is submitted, so it may sit there for a long time and have significant consequences. But if you can make the code a cleaner, happier place, if you can rename some variables or tweak some style to make the code easier to read, you should do it. In giving feedback to the community about that, and the gentle part of this is, the code that you're touching may not have been modified for years. It's possible that whatever rule you're applying to clean the code up didn't exist when that code was written. So be gracious about it. Don't be a jerk and complain to people that they're not following their own rules. Just say, hey, I observed that we're not following the rules and I took care of this. And that will be well appreciated. I'm going to check the time. We're doing okay. So disciplined. I debated where to put this slide for a while over the past couple of days. I think this is where it fits. I've just given you a whole bunch of guidelines and thoughts about, clean code and validation and testing and things like that. And I think it's important that you remember to be disciplined. In the case of a project that's greenfield or brownfield, or just a general dumpster fire and mess, you should always apply discipline and rigor to your approach. Just because the system is a mess or doesn't conform to your degree or your level of code quality and professionalism, it doesn't mean you should compromise your principles and your beliefs about how software should be built. Use your own guiding principles and your own good judgment to apply these changes, whether it's open source or professionally, right? And don't compromise. The answer, especially in open source, might be don't do the work here. Opt out of the project because you don't agree. And that's okay, right? Don't feel bad about that. You want to raise the bar, as they say, on quality wherever you can. So don't abandon your good practices just because the rest of the community doesn't want to follow them. And if you can't compromise and make that work with them, it's okay to step away. So the rest of this is more generalized around just developing software in general, whether it's open source or otherwise. But I think there's some interesting good hooks here for even the open source community. I just went backwards, sorry. You want your code to be demonstrable. You want the change that you're making to be visible to people, and you want to demonstrate it as early as possible. So when you're thinking about a change, whatever that change may be, you want to be always conscious of, and how am I going to demonstrate this? How am I going to show from end to end an entire process has been affected by what I just did, and it's been affected in a useful way? And then you want to try to get to a place where you can demonstrate even a fraction of that change as early as possible, and then make that demonstration periodically. In an open source community, because it's mostly asynchronous, you may not have the opportunity to demonstrate that to others as often as you'd like, but you can make sure that your branch is in a state where somebody could observe it, and in your conversations with the community, recommend that they pull your branch and go try it and show them what you're doing. It's a great way to get feedback. I think you'll get more mileage out of that professionally than you will in an open source community. But if you're working on something significant, being able to show that it works and show what the results of your changes are as early and often as possible is super valuable. And doing it in an end-to-end way, where we're talking about from the moment that the user input is created to the effect or change has happened, right? so like at system test level, right, gives people a sense of what's really happening in here, what's the utility of it, and assures you that you're going to get the outcome that you want. The next bit is about test-driven. So I'm a huge proponent of test-driven development. I don't really write code if I'm not writing tests. I have, spent, I don't know, 20 years now or so since I learned test-driven development. At one point, I had to think for a minute, how do you run a Java program straight up? Because I'd only ever done it with a test for so long that I'd kind of forgotten the obvious public static void main, which they just changed, by the way. Testing and doing test first activities is really powerful. Test first really is a design technique, right? It's about understanding what I want the system to do, which sort of shapes my design and shapes my thinking of the implementation. And then the side effect of that is I get some unit tests that help me know that the system still does what I want it to do. There are other techniques, behavior-driven development, acceptance test-driven development, which they're almost the same thing, but not quite. In all of these cases, before we start, we're thinking about, well, what should be true, right? What should be true when this is done? Those tests help shape and guide what am I going to build? How am I going to build it? And how do I know when I've finished what I'm trying to do, right? And then one of my other favorite features of test automation and testing in general, right, is those tests effectively become executable documentation that prove the system does what it says it does. And if they're built consistently and well, and they're we believe in them and they're trustworthy, then we know that we're not having negative consequences on the system, and they can act as an assurance that the quality of our work is good. So if you're not familiar with test-driven development, if you haven't gotten into that world, I highly recommend it. Go read Kent Beck's test-driven development book. Go read about it on the internet. I've got some demo videos on my YouTube channel, shameless plug. I don't publish there very often, but if you want to see somebody do it live, Amitai has a lot of resources, Nilanjan has a lot of resources. I would strongly recommend that you check it out. And in a lot of open source communities, a pull request without tests associated with it will be rejected. Yes, I'll get you a link to the channel. Continuous integration. So in your open source community, this may be less accessible because open source communities often don't have a lot of funding and they're not running a full-on CI server. That said, many of them use Travis or have agreements to use things like Circle CI or even using GitHub Action. So when you make a pull request or when you make a push to your branch, it will trigger those builds and run them for you. Continuous integration as a tool is super helpful because it gives you, that automated server gives you the ability to validate your code and run all of the steps, some of which may be difficult or time consuming on your laptop. So if those resources are available to you, get on there and understand them and understand what they're doing. But continuous integration is really not about that build automation. It's more about the fact that you're constantly or nearly constantly up to date with the rest of the code. So periodically rebasing your code or remerging the master branch into your code to make sure that you're in lockstep with all the other developers, and periodically pushing your code so that other people can access it is super important. That's how we avoid the inevitable painful merge conflict or the conflicting features. So when we go to test, the tests suddenly don't work because we've made incompatible changes between two things. Or when we demonstrate to a product owner, they don't, they're surprised at how things now work because we haven't stayed integrated. So the real part of the practice that's important, more than that build automation that we always talk about, right, that automated server, is I'm always up to date, or I'm always as close to up to date on the code base as I possibly can be. So my practice is 3 times a day, I rebase my branch. I go out and I say, pull down all of the latest stuff that my friends and compatriots have built with their good labors and merge that into my world using a rebase and make sure everything still works. And then when things don't work, it should probably be my fault, right? You want, by the way, only ever rebase if the build is green, but rebase, make sure everything works. Then, if it doesn't work, probably the problem is with my code, right? Because I'm building on top of what they're doing. So think about now change my code to work with what everybody else did. That practice will save you a ton of suffering in the long run, because when you get to the merge request, the number of things that are in conflict should be much, much smaller, if not zero. When when you do have a merge conflict, it should be minimal, it should be small. And if the features are incompatible, it should be pretty easy to identify. So big important practice. Don't neglect that, even in the asynchronous open source world where maybe things are taking days. Professionally, you can be doing this more than 3 times a day, I'm sure, if you want. Exploratory testing. So great story from maybe 10 or 12 years ago. I had a group of superhuman developers. They were fantastic. And I was their tech lead. And we were absolutely convinced that we were the bee's knees. We were going to do everything so well that we would astound the universe. And we worked and we worked and we worked that first sprint, and we built everything, and we did our demos, and everyone, oh, wow, can't wait to see the UI, because the first part was just sort of a scaffolding thing. We worked and we worked and we worked. We got to the end of that second sprint, and we went to demo to our product owner and realized that we had not attached any of our new work to that original scaffold. And so we failed to do exploratory testing. We failed to actually stand the system up and play with it and make sure that it worked. We were too laser focused on our unit tests, too laser focused on our build automation, too laser focused on a lot of details, and we forgot the important part, which is we didn't deliver the value to the customer. We didn't make sure that it was connected. And it was a little embarrassing, but it was this, second sprint. Everybody just kind of laughed, and we fixed it. Don't forget to do this. If you make a change, if you've got, let's say we're playing with Cucumber and we're adding a new feature, go apply it to something that isn't the Cucumber project and see if it works. Make sure that your feature works and that all the other features still work and that you didn't break something, because, that would be a bummer. So don't skip that step. Another piece of useful information is tooling. So in general, right, you want to be super familiar with your tools. That familiarity and skill set with your tools is essential to your productivity. It's what differentiates you from an amateur. Ironically, I am the worst VS Code user on the planet. I've just not embraced that product, and I'm not very good at it. And a lot of the folks I work with use it. And I always feel like a fool when I join them on a project and I can't use the tool because I've used a different set of tools. But when I use my tools, which I use WebStorm for web development and PyCharm for Python development and things like that, right? I know those tools inside and out, and I know what they're capable of, and I explore them and go and look for, hey, can it do this? Does it have this feature or this capability? Knowing those tools and getting good at them, super important. When you join an open source community, though, some of those tools you're not familiar with. Some of those tools you might not use professionally, or you may never have heard of them. Get curious, go explore them, take the tutorials, learn them well. Not only is it learning, which we all love learning, right? Not only is it learning new stuff, which is fun, but it will make you much, much more productive and much, much more effective within those teams to understand those tools and how they work and how they're leveraged. And it will, probably reduce some of your frustration level. Extras. So I didn't have a good slide title for these sorts of things, so I just sort of created a space here called extras. And again, these notes are all going to be, shared with you. So I'm going to kind of rip through a couple of things that you want to think about. When you're building systems, whether it's open source or otherwise, you want to keep in mind some of those fundamental software engineering principles. So for example, high cohesion and low coupling. You want to make sure that you're not creating a dependency nightmare within your code base that makes changes difficult. A friend of mine once said to me that the purpose of software engineering is to reduce the cost of change. One of the things that we want to think about is I'm creating a change in a system and I want to make that change relatively inexpensive. So as you think about the change that you're putting forth, make sure you're doing it in a way that it's relatively inexpensive to make this change and to change it once it's there. And that goes into, design patterns, and it goes into approaches from solid, so single responsibility principle, Liskov substitution, things like that. Think about those things as you're working in those code bases and understand whether or not that works with the rest of the system. Because you may be working with a bunch of people who don't believe in inheritance. And so maybe they aren't big fans of subclasses, and you need to think about interface implementations. And that's true in your own code bases, professional code bases as well. So think about that stuff. Think about things like domain-driven design and hexagonal architecture, dependency injection, things like that, as ways to encapsulate your changes and make your work effective without having a negative consequence on others, right? By coupling your code together and making it, now every time they touch it, they have to drag your feature along with them. Hold the line and raise the bar, right? As you think about quality, as you think about style, as you think about technique, and as you think about sort of the ethical purpose of what you're doing, don't give up on your own principles. I said this before, but it bears repeating. It's really important, both to you personally and to the world, that you stick to your guns on what you believe and have, rational debates. And it's okay to change your opinion and your thoughts, but hold the line and don't just accept lower quality standards or lower, unethical practices or anything like that, right? And you do that through, communication and training and education, right? Both in your organization and as you join an open source product. It's okay to raise your hand and say, I have an objection here, and here's my reasoning, and have that conversation. And pro tip, in order to communicate that well, right? Have a why. Be able to explain why you're objecting. Because just to say, in my experience, I object, doesn't get you very far, right? Most people will dismiss your argument because there's no evidence that you're right. There's just you saying, I think I'm right. So being able to demonstrate to people why you're right, or explain or justify whatever changes you're talking about, it's an important skill. And it's harder in an open source community because it's an asynchronous communication, because you're dealing with people who, you may never have met and may have only exchanged a few messages on, IRC with. So when you're making these changes and you're being questioned, keep that in the back of your mind. Don't compromise easily. Be sure that you're, fighting the good fight and that you're holding that line. Related to that, sometimes state the obvious because it might not be obvious. My good friend Dave Dierker once used to say to me, common sense isn't. And I found that kind of frustrating, but he's right. What I think is common sense, what I think is natural and normal, might not be obvious to others because they don't have my experience. They didn't grow up where I grew up. They didn't read the books I read. So sometimes it's okay, it's necessary to state the obvious, and that can help you in those conversations. Raising the bar, right, is about there's always room for improvement. No matter how good we get, there's always room for improvement. I write code, 6 weeks later, I look at that code and I'm like, what was I thinking, right? I could have done better. This variable name is bad, this method name is bad. This is formatted poorly or structured poorly. So always be looking for ways to improve and bring those things to the community. Hey, y'all, I see that we're doing this. I think we could get a better result if we did something else. A specific example might be, we have a lot of singleton patterns applied here in the code. And I think that those singletons are inhibiting some of our capability around state management. And I think that we could do a better job if we used a factory pattern, or if we used, we synchronized this information through a database instead of what we're doing today, right? Bring those improvements forward and talk about them. At a minimum, you will learn from others their thinking and their reasoning for not having done that. And you may also get the joyful experience of everybody going, wow, that's brilliant, you're right, let's go do it. Part of that requires you to take some time to reflect on the quality and speed and effectiveness of what you're doing, right? And this is important both in open source and professionally. If you don't take that time and you don't reflect upon what you're doing, the improvements will come very slowly, if ever. So retrospectives, quiet time, study hours, somewhere in there, think about the processes and the techniques and the tools that you're using, and think about what could I improve there? What could be better? And then go after it and try to figure out a way to make it better. Part of that, just tangentially, right, is measurement. So as you do all of these things, right, one of the things that seems to happen a lot is it feels like and it seems like it's bad. If you can measure it, then you can tell whether or not it's bad. This seems like it takes a really long time. Okay, well, let's put a clock on it and measure how long does it take. That's super informative and helps you from wasting energy on things that just feel bad and aren't. My favorite topic, technical debt, right? So in an open source community, what you're probably going to experience on a regular basis is technical debt. Sections of the code that have worked for 10 years and nobody's touched them. And they're full of sort of divergent thinking, right? Technical debt, its original definition, is more or less the difference between what is understood and what is implemented, right? So we understand that the system is supposed to do this or should be shaped like this or formed like this, but we haven't changed the implementation. That's the debt. That's the thing that catches up with us. And that entropy, right, can eventually stagnate a system. We can't move forward anymore because the implementation is so far away from reality that you can't reasonably make changes to it, right? Thinking about that, looking at the systems and understanding that in terms of your project is really important, because you don't want to create any of it, right? You want to fix it as it comes, and you want to have a plan. So Doc Norton once said, it can't be technical debt unless you have a plan to fix it. And he was talking specifically in that case about, the compromises we sometimes make in an implementation. We don't know how to do this any other way, but we know that the way we're doing it isn't the best way. So we're going to do, quick sort where we probably should have used something more sophisticated as an example. And we have a plan to fix that. We have a spike set up to go do some research and find out if there's a better way to sort this data, or a faster way to, preload it from the database, or shift the computation back into the database, but we don't know how to do it. That's the plan, right? And then we put that plan in the backlog and hope that one day it gets paid attention to. A note about technical debt is often referred to also as having not done the maintenance or having not done a complete and professional job. That's not technical debt. That's cruft. That's, I didn't do the right thing, or that's maintenance. I didn't pay attention. Some of the systems at my company have that problem. We haven't even compiled them in 5 years. And it's scary because we think about that and we go, well, do we even have a build chain that can work here? Those failures, I don't think you'll experience them too much in the open source community, although you might. Those failures can be potentially crippling, so pay attention to them. I built, it's not really open source, but I built a demonstration for a client a couple of years ago and published it on my GitHub account. And I think it was last year, I received a note from someone saying, this no longer works. It needs to be fixed, as if I was just going to jump to fixing it, right? And I'm like, okay, that was a demo I did in like 2012, and it doesn't work because you can't even get that operating system anymore, right? Like, There's no Docker image that works here. If that had been essential, if that had been important, right, then I would have been just as guilty as so many others of having not maintained my stuff and kept it up to date. Comments and clarity. So I love this little screenshot I found, right? Don't use this variable. This kind of goes to a lot of things that you've heard probably through Clean Code, through Tim Ottinger's blog, through many other people, and I'm in this camp of the documentation we need to write is the essential documentation, and the essential documentation is why is the system the way that it is. What is the metaphor? What is the intended structure and purpose of this code? Documenting the code in most communities is a waste. The code itself should be readable and structured in a way that it tells you what it does. So having said that, some open source communities insist upon you writing a lot of documentation, and you should pay attention to those guides and those rules, and you should conform. But I would strongly suggest to you that you consider the test cases, the BDD style given when then cases, as the explanation of how and why this works the way that it works. And structure and format your code and name things well in your code so that the reader is not scratching their head and wondering what's the difference between X and Z and what is this variable P over here for, but rather I understand that X and Z are two cool parts of a three-dimensional coordinate and P is a pointer, right? Spell it out. In this modern age, variable name length is not much of a concern. Function name, method name, class name, we can be expressive. So do that, and do that to help avoid writing unnecessary documentation. And related to the specific screenshot, if the variable shouldn't be used, the variable shouldn't exist. So take it out. Get rid of all of the dead stuff. It's just clutter and noise. Last thing, almost last thing, considerations that you should make. There's a semi-famous quote out there that says, always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. That was said by John F. Woods in, I think, the 80s sometime. Understanding that what you're building needs to be maintained either by you or someone else in the future should guide your principles in how clean and how well you do it. You will save yourself personal pain and suffering if you do a good, clean job and make easy to understand, comprehensible code with good tests and the appropriate documentation. Because 6 months from now or 3 years from now, you may be asked to go back and do some maintenance on that, whether it's from your open source community or professionally. And if you've done a good, clean job and you've been a good professional, you will have much less pain than if you just say, hey, I need to put this slapdash change in here real quick, and I'm going to not format it well and use terrible variable names, and I'm not going to write any documentation. 6 months from now, you're like, what was I doing? I don't remember. Or 3 years from now, it'll be even worse. Did I really write this? So I like that quote because it reminds me that, one day somebody else is going to be trying to maintain this and they're going to be really frustrated with me, and I don't want people to be frustrated with me. So this is about patience, right? Getting into open source and getting into software engineering in general, right, is in part a patience game. I know you all want to move fast. I want to move fast. I'm pretty ambitious. I tend not to want to, dilly-dally with analysis and reading and thinking. Sometimes I just want to jump in and write code and solve problems. And I would recommend being patient, right? Be patient with yourself and be patient with the community you're working in. You have to give yourself enough grace to say, it's okay for me to make mistakes. I'm learning from those mistakes, and those mistakes are making me better. And I have to have some patience with myself. And when you're working with a community, especially in an open source situation where some of these people are thousands of miles away and also have day jobs, and may not understand what you've done or understand it and have lots of questions, be patient, take a deep breath, and work with them, as friends and as a member of the community. And as you bring new ideas into a conversation, you may have a visionary idea that's going to change the world, but you should not expect that people will immediately take it up and assume and agree that you're right. So having patience with the process of explaining it. I tell my team, it's sales and marketing, right? You have a brilliant idea. We're going to solve a huge business problem this month with this change that you're proposing. But we can't assume that everybody involved here gets it. So we have to market the idea. We have to listen to the feedback. We have to resolve the objections in order to sell it. So if you have a radical idea to change an open source project, you're going to go through the same process of trying to convince people that your brilliant idea is in fact brilliant and that it should be accepted by that community. A lot of that's related to your curiosity, right? A lot of that's related to you taking the time and having the empathy for the people around you to understand their perspective and understand where they're coming from with their objections, right? And you should do that in an open-minded way and accept that, they may have perfectly valid concerns that you didn't consider. And that may lead you to say, well, okay, we're not going to do that here. And maybe I'm going to go create my own open source project where we will solve that problem. Also, I guess it goes without saying, but I'll repeat it or say it for the first time. Not all open source communities are the same. The Linux kernel group is not like the, CanCan team or the Gimme team. So you're going to have to learn the norms within those organizations of how you sell an idea. That's why I said earlier, you should really find out who the community leaders are and befriend them. Learn who they are and what they're thinking and establish a relationship, because as you're trying to propose new things, having that relationship will be super helpful. They'll be able to help you navigate and help you with that sales and navigating thing. Last bit, I have a reading list in here, a bunch of recommended books. I mentioned Kent Beck's TDD by Example book. There are many other good books, and this is certainly not the whole list, but these are some of the heavy hitter top ones. They'll help you understand how software is structured, why it may be structured the way it is, and how to think about what you're reading and what you're learning reading it. So thank you very much. I think we're going to open up to a Q&A thing. And I'll verify that that's the right YouTube channel. And if it's, because I actually have two of them. But what are y'all thinking? What are your thoughts? Who's got a question?
Precious. Thanks, Rich. That was awesome.
Yeah. So, thank you very much, Rich. Yeah. At the part where you were saying, "Oh, hold your ground. Don't don't move. Don't leave your principles." I think it even goes beyond coding, right? So yeah. So if can we like use an emoji to drop your favorite emoji? Reaction. Can you please kindly react if you really enjoyed the session? So I can see Donald and see Franklin. All right, thank you very much. Keep the reactions coming. If you really enjoyed the section, yeah, I can see Nilanja. I can see Ezekiel, God, Law. Thank you. All right. So yeah, it's time for questions. If anyone have a question, any question at all, I can see those trying to ask some questions in the chat box. So if you have any question, you can drop it in the chat, or you can just raise your hand, and then I will unmute you to speak. So if you have any question, any contribution, anything you want to say or you want to suggest, just use the raise your hand, and I will allow you to come and speak. So yeah, any questions? Any question? All right. Since there is no question, I think okay, I'm not seeing any question for now. All right.
Let me ask one.
Okay.
Um, so Rich, one of the things that that happens with open source, right? So you get to the project, you're probably using that library or tool, but you never looked at their code base, obviously. So you see an issue, maybe you're having that issue. You realize the documentation said something, but the code is actually not working that way. And you have time in your hand, you said, okay, let me try to make a contribution. So you clone the repository. It's completely unknown code base. You know the language, you know the technology. How do you do that? I mean, what guidelines you follow when you tackle an unknown code base?
Yeah, that's a fair question. So I'll use the change I made to Cucumber as an example. So one of my successful changes in the universe was to Cucumber. The scenario was that we were using Cucumber to validate some embedded code written in C++. And Cucumber has a framework for doing that. And we discovered that if the C++ program crashes, Cucumber responds with a weird error message that says strings don't have, or sorry, nil does not have a toString. What turned out to be true was the documentation. This is why documentation is dangerous. The documentation for the Ruby library said, if the network connection drops, you'll get back some kind of an object that tells you the network connection dropped. And the truth was you got back a nil. And in Ruby, nil, which is the Java equivalent or C# equivalent of null, you can actually call methods on it. And so if you have a nil, you can call is nil, and it will tell you if you're talking to a nil. So what I did was I pulled the entire Cucumber code base, right, which is huge. And then I explored the code base first by saying, well, how does a test run get initiated, right? How would I even get to running a scenario within the tool? Okay, I understand that now. How are features selected? And then how are steps selected within the feature? Okay, cool. I understand these things. So I literally tracked down the code by starting at the entry point, the main method, and focusing on, I want to find out this, right? How does a scenario get started? Once I found that, how does this next part happen? How does this next part happen? When I got to the steps, I could then dig into, and how is an error reported, right? And so if you dig through that code, you'll find, okay, it basically got a try-catch block that says, I'm gonna execute this code, and if it fails, I'm gonna call these methods to get the output, and I'm gonna print it. Great. So now I understand what's going on there. Then I went and I understood how is it that the mechanism is testing against the C++ code, because Cucumber's Ruby. What is it doing? Okay, dig through all that code. It was pretty weird, but basically there's this thing called the wire protocol in the basement of the code base that says, I'm going to use the network to talk to another program to execute the steps. So I learned how that worked and walked through all of that. Okay, what's a test scenario that I could create that I can show myself, what's going on? So I wrote a C++ program that would blow up immediately. By just throwing its own exception, it would crash. So it's able to reproduce my problem. And then I started tracking down where in that wire protocol stack is the error occurring, which, not surprisingly, was on the receipt of the response from the C++ code. Okay, so I know where it's happening, and I know how the error is being reported back out. Now, what do I need to change in this code base to report the error as the C++ program crashed, as opposed to reporting nil does not have a toString method, right? And it turns out my change, I think I wrote 25 or 30 lines of test code, and I wrote one line of code to make this fix, right? So it was a tiny little contribution in the end. I anticipated it being a big complicated thing, but it was pretty easy. Yes, Amitai dug up that merge request. So that was how I did it. It was like, what am I trying to fix? Well, I'm trying to fix the error report. Okay, so go dig up, how does the error report get there? Okay, effectively it's taking the exception that's thrown and printing it. That's not very exciting. So how does the exception report get created? That got me into the wire protocol. And then once I was in there, I was able to very quickly figure out, well, yeah, I mean, I already knew this part, right? You're calling toString on something that's nil. That's the problem, but where? So I just kept having to track it down, and I created a working test case that showed me this is the problem. And then when that working test case started, or it failed, right? It was giving me an error. When it started passing, I knew that the problem was resolved. And then it was a matter of, and how do I do this within the context of how they test and where they test and the tools that they use, as opposed to, well, I proved it for myself and it's good enough. When I made that contribution back, I needed to provide the evidence so that if they ever broke it again, the test would fail and they would be, oh, hey, Rich's thing doesn't work anymore.
Makes sense. How long did it take you to do this?
It took us, so as a community, we figured out the problem initially pretty fast, that the problem was the C++ program was blowing up. And so we spread the word, when you see this error, that's what's happening. I think it took me 4 or 5 hours total to fix it on a Saturday.
Okay.
I wish I could tell you it took me days, but it took me 4 or 5 hours of good laser focus. Cucumber's big, but there are plenty of things like Tomcat and whatever that are, super huge. Tomcat is a beast. And I've thought about it's been a while, but I've thought about making some contributions there. That community is different in the sense that they're complying with a very strict contract of what this thing should do. So making changes there is a lot harder. You can't really add something beyond the servlet specification very well.
Yeah. Thank you.
Oh, thank you very much for that, Rich. Thank you very much. All right. So, okay, Nee, you want to say something? So, I don't know. Does any other person have a question just before we let Rich go? All right. Okay. So,
let me say, y'all should feel free to email me if you think of a question later.
yeah.
I occasionally look at Twitter, but email would probably be better. And I'll put my email address in here. I have this is my older one, which I seem to have added an extra @ symbol to. But that's I used to have my own company, and that's the email there. Be a good way to filter it out.
Oh, okay. So just to be sure, it started with @rpd @noradltd.com, right?
Yep.
All right. Thank you, Rich.
You're
All right.
welcome.
So guys, thank you very much for coming for this session. Then little announcement about our upcoming internship. So we have an open source internship coming up, which is why this session is very, very important, which is why we insisted that we must have this session today, right? Because it is an open source internship. We'll be accepting people, and we want to hold your hand. For those that applied, we design this very interesting internship, and we want to hold your hand from the time you make your first contribution to the time you make your last contribution. And then we have a lot of interesting things coming along with the internship. We have mentorship. We have an AI that is going to assist you all through the period of the internship, and you have your personalized Tublian dashboard that is going to help you, to make sure that you contribute to the right projects. You don't get projects that will come and then maybe they're not in your particular skill level or something like that. Remember, Rich talked about, discovering a project, knowing about the project health. If you log into your Tublian dashboard automatically, right, any project that you see on your dashboard, first of all, when you log in, you are going to see projects that are related to the particular skill that you have, because we've analyzed your GitHub activities using Copilot AI, and then we are suggesting projects based on your skills. And then when you look at all the projects on the dashboard, you look at it, you're going to see the health, which shows you how healthy is this project. You're going to see when last someone contributed on that project. So you don't even need to dig around a lot for you to be able to know if a project is worth your time or not. So you can easily see the issues aligned there, and you will even know if you're a beginner, you don't need to start contributing to a professional, or a project that you don't have the particular skill set to contribute to, right? So once you log into your dashboard, you're going to see beginner projects. Then another very important announcement is that Tuesday is Sunday is October 1st, and in October, we know what we do as developers is Hacktoberfest time, right? So it's open source time, Hacktoberfest. So on your Tublian dashboard, when you log in by Monday, you are going to see a tab where you are going to see all the projects that are listed under Hacktoberfest. So, and we are going to filter it for you based on your programming language. We are giving you projects that you should contribute to in line with Oktoberfest. So log into your Tubulian dashboard by Sunday, and you're going to see projects that are well tailored to your particular skill that you should contribute to in line with Oktoberfest. And of course, we have the co-pilot who's going to help you guide you through the process of contributing to this project. So once you click on a particular project, it's going to analyze, tell you, oh, okay, this is what the project is required of, this is what is required of you to do on this particular issue, not even just on project, on a particular issue. It's required for you to, so you don't need to be added to the dashboard. Just create an account, you have your own dashboard. Right? Just create an account on tublian.com, then you have your own dashboard. So when maybe I should share my screen. I don't know. I didn't plan on sharing my screen, right? So, well, let me try to get my screen up. So when you log in, you are going to see um everything about a particular project. The co-pilot is going to explain to you. This is the first thing you are supposed to do. You are supposed to maybe they want you to change a particular language, maybe things something is written in China and they want you to write it in English. The co-pilot is going to guide you all the way through, right? So that's like that's the updates that we have based on things that we are working on recently. And then on the internship is starting on Monday, and then of course, yeah, we did a call for mentors. So if you are here, you want to join our mentors group, you can also just reach out or indicate on Discord, and then we can get you in. We are looking for like well experienced people to help us, mentor the other people on how to contribute to this open source project. So the internship starts on Monday. The activity lineups, of course, you are going to get it during the internship onboarding call that we're going to have probably on Monday. Um, the other thing we are so if you have any question about the internship, feel free to drop it on the comment box, or you raise your hand. I can always unmute you to come and speak. Just feel free to speak, raise your hand. You will be unmuted. You speak, ask your questions. If you have any question, you're having confusion or anything about the internship, just ask in the comment section, or mute yourself and ask. So also, we are still on the selection process. The selection process is still going on. We are hoping that we'll be done by tomorrow. So from tomorrow, some people are going to start getting emails. So from tomorrow, next tomorrow, people are going to start getting emails on if they're accepted into the internship or if they are being kept waiting. So we talked about this yesterday during the community call, that if we do not accept you in this session and in this edition of the internship, right? Because we got like a lot of interest, a lot of people applied for the internship, way beyond what we planned for, right? So, but we are trying to accommodate as much people as possible. But in case if we don't accept you this time, just chill, relax. We are going to accept you in the next cohort. So the next cohort is coming up in months' time, and then you're going to be accepted into the internship, right? So yeah, the last thing I was supposed to talk about today is the um the co-pilots, no, the competition that we did, right? So we did some competition months ago where we said so meanwhile, if you can see my screen, this was what I was talking about. We have categories now, so you can easily like filter projects. This is Angular, this is TensorFlow, I think. Frameworks, you can filter by frameworks, libraries, backend projects, Python projects, front end projects, beginner friendly projects. Now, we are so this is where you're going to see in one of these tabs, you're going to see Hacktoberfest. It's going to appear somewhere here. You just click it and you see all the projects that are associated with Oktoberfest. Then when you look around here, you are seeing this particular project is not good. the health is bad, and then activity is low. I don't need to, spend a lot of time contributing to it. But then when I look at something like this is at high activities, 57 PRs per week, and then the health is very okay. So this kind of project that I might want to consider, contributing to, right? So, and these are all, if you open your own, you're probably going to see something different because, of course, my skill and your skill, we don't have like the same skill level and the same skill set, right? So I really think you guys should check it out. So yeah, last thing the last thing is also that, so let me finish talking about the competition. So the competition, the winners will not be announcing them today because I was just told that we have to make some, we have to like look through again, right? So yeah, we are still like in the selection process. We're almost done. So you are definitely going to get an email once we are done, and we're going to announce the winners. So if you remember when we started the competition, we called it Tublian Challenge. We said that the prize for the winner is $100 for the first position, $75 for the second position, and $50 for the third position, right? And we ended this on the 22nd of September. And this was like a very simple, project. Just use ChatGPT to build a Discord bot, and we had like a lot of amazing submissions, like amazing. I tested some of them myself, and they are really, really amazing. Like I could interact with my Tublian, I could interact with Tublian just from Discord, and it was like amazing. So we are still trying to like select who is going to be the person to go with this $100. And then definitely you're going to get a mail. We're also going to make announcement in the community. So make sure you're in the community, and make sure you're in the community, and so that you get this information as they are coming. All right. So am I forgetting something? So maybe Neil can. Am I forgetting anything?
No, no, you covered everything. I want
All
to
right.
just say final thank you to Rich. I know you're a super busy person. Thanks for taking the time and sharing your experience and thoughts with us. It was really valuable for me too. I'm pretty sure it's going to be valuable for everyone else. I know lots of people were not able to join or drop off early. We recorded this call. I'm going to stop recording now. We will definitely share this video with you in our community and post it on our YouTube channel so that you can catch up later.